Hi, and welcome to another stream. I'm going to give it a shot. This is the second time I've tried this one as well. Last night I tried it, and then about 3 minutes in, the sound just went. My mic went. So hopefully my microphone's going. I mean, it says it's going. I guess it's good when you have people watching because then they can give you that feedback. But anyway, this one's about blast face design. So I'm going to talk about blast face design. So it's a bit of a deviation from what I've been doing, which is timing. And going to talk about how I would probably design a face. And I'm going to be using Paradigm again. And yeah, so let's have a look at... let's get straight into it. Also, I would note that only of all the viewers that I've had on YouTube, only like 98%, it's pretty bad, 98% of viewers are not subscribed. And so if I'm to grow the channel to get monetized, I need subscriptions, and that way I don't need to beg for donations. You know, as I do videos, I'll get paid by ad content, I suppose. So if I get my viewing hours up and all these other things associated with YouTube, then I will be able to make a bit of cash from this and keep providing information for free. Obviously, in this time, it's important to have a bit of income. Rightio, moving on. So I'm going to talk about this blast design. I've built a surface in 3D, in a 3D program. In that 3D program I showed you last time, I built a surface there just so I could do this. I don't have access to survey scans at this stage, so the best I can do is design, make my own stuff. So this is like a 12-meter bench. You know, just a bit of undulation there in the surface so that we can get different hole lengths and depths. But this is just a sort of like a play surface, and I brought that in. And what I have also done is digitize a blast block, or what a blasting boundary, or a blast master. So this is the zone that we're looking to design here. But as you can see, it's got a face, and that face is relatively firm. You know, it's not full of fill and stuff, so it's a little bit of a problem with the 3D stuff there. Anyway, so I've digitized that, so we're going to design the face in here, and I'm going to try and get across two methods for design. One will be baseline design, and one will be just digitizing the toe and then offsetting that toe by your minimum toe burden that you were looking for, and then projecting up from that toe burden to the surface with holes, angled holes. And we know what our angle should be once we digitize this toe. It will be a wobbly line, and then we can look at the face angle, and we can say, well, we want holes at this sort of angle, and we can project off that with our collar to toe separation. So I've also got a little Excel spreadsheet here, and so, you know, just here is, it's simple. It's a tangent on radians, and that'll tell you how to find the collar to toe separation at depth over an angle. So if you're looking, it's pretty easy calculation, E3 times. I'm sure many engineers already know this. It's simple geometry. Most of blasting is simple geometry, and this is so pretty much we're just looking at a length and an angle, and converting that from that angle into radians, and then applying a tan onto it, and then we get this separation from collar to toe. So we're looking at around the, so I've just set it up here. Oh, let's cancel that. I've just set it up here to be these depths. And so if we had a 20-degree face, our face was 20 degrees. Let's see if that's going to work. No, I've got the, there you go. 20-degree face, or 20 meter bench, sorry. 20 meter bench with a 10-degree face, where we're sort of like just drawing a line through here, and we get this value down here. 20 degrees at 10, it's around 3.5. Yep, 3.5. So we're looking at 3.5. So that's just saying that that from, obviously you might know this, from the collar of the hole to the toe of the hole is going to be an angle. Now if you drew lines directly up from those and directly down, the distance between that, the planned distance, would be 3.5. So that's suggesting that your collar, where you place your toe or where you aim your toe, should be 3.5 meters away from the collar, which means then your next row of holes is going to have additionally 3.5 meters of burden attached to it. It's going to have another 3.5 meters of burden attached to that. Really cool. It's a pen. Rightio. Maybe I'll draw that up later. But essentially that's what we're sort of looking at. So if we go back here, we'll see this in this sort of like this cross section here. Now I'm using Paradigm again. It's a program I have access for, and I'm learning it myself. So this is really good for me to do these streams, because I can teach you and me at the same time. And I find that teaching and doing pretty much hand in hand. A good teacher can do. Or that adage about those who can't do teach. That's it might be one tat, but they teach poorly and they teach badly. So so it's about being able to do and being able to teach. So hopefully that gets through. Alrighty, so let's start with the first method. I'll go back to the plan view. So it's quite, oh sorry, let me just put that back on. Here I am talking away, but there you go. I'm going to go back to the plan view. Here we're going to use Whole X Section tool, which is in Paradigm, and it sort of gives you a, we'll see this update when I actually put some blast holes in, and this gives you a, this is giving me a section for an old hole, but this gives you a sectional view and gives you minimum distances, and you can set this step length from 1 meter to 0.5 or to whatever your issue is. Maybe you do your design based on bore track rod length. Well, then you might, your rod length might be a 2 meter rod length, so maybe that's the intervals that you need, the step length. So essentially we're going to do two things. We're going to do a design of a baseline. So I'm going to turn those baselines on. I've digitized those. I don't know if you can see that. I had to increase the screen size so that you could see all the words, so that it wasn't all tight and small. And so what you're essentially doing here is, if you've got like a MDL scanner or some kind of scanner where you're going to do this design on the fly and you don't have GPS surveying access, or your precision on your GPS unit's not sub-centimeter, so you can't just do a design in the computer and issue that to the survey tool. So we're talking about cheating survey, sort of like in a cheaper, lower end design and quarrying environment. So this is the method I would use, and out from here you would draw in your mind's eye a bit of a angle. Let's draw a little point in here. So we're sort of like suggesting that we're going to have a scan of this area, So we're sort of like looking to scan this area through here. So we set up our scanner, and then we would think about what we're going to do over this side, and maybe we want to do a scan over this side as well for the second face, and we probably want to make sure that we get a bit of an overlap there. So you can see here I've already set my scan up wrong on this one, because I need to capture, I'm not capturing the baselines, I'm trying to capture the face there. So let me just move that out there. So we want to over scan, so that we want to look at that face. Oh jeepers, let me just close these off so we can see the screen a bit better. Here, we'll put that over there. Right, finish line there you go. We can spread this out a bit. Let's see if that works. Just trying not to cut off the where my head is down the bottom, down here. So here we have so back here we would probably set up our scanning tool and do our face scan, setting up our baseline, right? Pretty easy. So let's just rename these. We'll call this scan 1. It's just I'm just naming it so that you can see what we're talking about. Scan 2. Oh, there you go. Scan 2, and so we've got those two sort of things there, but we don't really need to show that because we're doing this graphically. We're not doing it physically in the field. But anyway, we're talking about putting a pole up here and a little peg that you can see in the scanner, and you pick that off and draw your face polygon in the scanning system and that. So anyway, turning those off, and we jump back into this tool, drag that across a little bit. Right, so we've got this line here, and we're going to digitize this line with blast holes, and then we'll see what that face looks like. So we will use these lines, and we will generate holes along this line. So I've just put it in as a rough angle of the blast face that you want to achieve. You know, maybe this one's not quite right. Let's just quickly change that one to maybe that's like that. Maybe it's like that, or maybe it's like that. So essentially, this angle is going to produce the blast holes out from this perpendicular to that. Right here. Here we go. And this is fairly. You don't want to set it too far back from the face, because then you can't. What's the word? You run it. You start to put the holes in manually incorrectly. Anyway, by just doing bad deviation. Anyway, let's move on. I'll start. So we got a 102 mil hole. I'm going to go with a 13 meter hole. Why did I choose that? Well, let's have a look. I'm going to say that they're 10 meters. We're looking at a 12 meter bench, 13 meter bench, or 13 meter length of a blast hole, and at 10 meters or 10 degrees on the face, we're at a 2.29 separation. So I'm sort of like aiming for 10 degrees. Okay, so and so that's going to be about 13.2 meters with the angle onto it. And so we're not going to use this offset. We can do that, and we're going to use a 3.6 spacing along there. So I'm going to create these holes. Now, I've picked the wrong line. I don't like that line. That shouldn't be the line. We're going for baseline 1. Right here we are. Kind of fits well. I mean, we can design these first and then drag them along the line, but I kind of like that. That's okay. Not too bad. We could probably choose a different system, but let's go along the line. All right, and we'll just create these holes off this corner, because these line up relatively well with what we're doing, and for our purposes in this tutorial it's fine. So we'll just create those holes. Okay, so we've created the blast holes, and then they have generated the angle or their orientation, which is really good, and that's excellent. And then we're going to, well, I messed this up by making that small, didn't I? So we will slide that up a little bit. I'm going to increase the angle, so we're going to go with 10 on all those holes, and here we can see this profile line, and we're pretty much done. This is good. Right here. So here we have our holes, and they're bearing off that. So that's just off the baseline. Now that's not all that we're doing here, because over here I've set up a danger distance of 2.8. I'm suggesting that my minimum face burden and my targeted face burden is about 2.8. So But we're going to, because this is a quarry shop, we're going to be manipulating the angle of the blast hole, you know, to match the face. So these blast holes will be wobbling in and out off this line. They'll be moving forward because we need to manage the toe burden and the crest burden. We want an even and consistent burden across this blast hole as much as possible, especially when we're designing, because the drill's going to come in and probably drill off and deviate perhaps, and that's not going to be very good for anyone. And with this tool you can actually load your hole profiles and stuff. I haven't done that yet, so it'll be interesting to see if I ever get a chance. So anyway, so we're going to go, we got this blast hole up here. Let's zoom into that and we'll show you what it's sort of calculating out at. So it's calculating at that this is the minimum burden. It's not even directly in front of the hole. So minimum burden is going to direct your energy. So straight away this hole is firing out, you know, about 20 degrees off its track line. So it's sort of like it'll look for the weakest part of the rock, the thinnest part of the rock, and that's where it will go first. And so this is very is looking all the way around that angle, that all the way around that hole, and it's looking for the minimum burden. So this is a really good tool. And you can see down here we've got one green dot. There's one value here that meets our criteria, so that's not good. All these don't. So we're going to take this blast hole and we're going to first of all try to line this red and yellow line are represented by these two colors up here, so that's kind of good. And this 5 degree line is what we want. So you know, you could set these to say, well, I want the face to fit between these two lines. So we could let's see if I can change that. No, can't change that color. So we could say, well, I want this to be 3.1. So now we have the line. You might not really see that line, but it's kind of separate. So we want to line up our minimum face burden, which is this section, this brown line, in between that. This black line is directly in front of the blast hole, so this we want to try to fit that in. So we can see here that it's slightly off. I'll move that back to 2.9 because I'm going to be fairly accurate with it. And we're just going to use 100 mils. We're going to nudge it forward or backwards to make this. So we're at 2.07 and we need to get to 2.8. So we could just nudge back 8 and write this down. We're going to write this down on a map so that when we go out to the field, we've got our baseline mapped out, and we know that zero chainage on the baseline, we move the hole back 0.8 for starters. So we can move that back 0.8. Oop. And if I was able to type properly, it would definitely happen. Right, 0.8, and we're going to move that back 0.8. We start to see that we've got it's starting to get close to it. 2.9 and 2.7, so this is probably looking like it needs to be angled out at 12 degrees. I'm going to say 12 degrees here, and we can see that we're getting more even. 2.67, 2.59. Yep. Okay, so we're going to move that backwards 100 mil. So we've written down 0.8 on our piece of paper. So we'll record that and we'll put this to 0.1, and we're going to move that back 100 mil at a time. So now we're at 0.9, and now we're at 1 meter behind the baseline at zero chainage, and we're now at 1.1 behind the baseline at zero chainage. We're starting to look a bit better. Now you don't want to, like, even though your crest is right and your toe is right, you don't want to be in the situation where you've got these red ones to start with. So we're 1.2 behind the baseline, backwards again, and we're starting to look so that's 1.3, 1.4. So we're saying, so straight away we're going to write down somewhere on a sheet, we're going to write our chainage of chain at 0, and we've got 1.4 behind, right? So 1.4 behind. So that's how we're going to manage that blast hole and that angle. So this is how we would design for a quarry shot. We would alternate the angles and adjust it, and your contract with your driller or your site-based driller this would be a key aspect to their KPIs, is to have zero or minimal deviation on their face, which means they need to take time drilling it. They need to drill appropriately for each of the rocks. So pretty easy. And then we can go to the next hole here, hole number 2, and we can see that we're well overburdened at the moment, and our face is kind of well off our angle. So let's adjust the face angle there at what did we say, 13? I think we'll go with a 15 degrees initially. 15, maybe it's 16. You can get 16 out of it. 16, yep. So we're hitting kind of 16, and we are now going to take this backwards by 100 mil increments till we're all green. Yeah, so there it is. So this is now the chain edge, your chain of 3.6, and it is 0.2 behind. Right? This is how you just go along your baseline and you measure off the baseline 200 mil or forward 200 mil or whatever the baseline suggests. So this is how you get your placement correct on your blast holes. And so we can go along and do all the holes. So let's see if I move quickly. I can go along and move all the holes. I think we're about 12. And we'll go forward. So that's a bit burning it up there. Probably too much. So I think maybe 14. I kind of like that. We'll go backwards. Rightio, so we're sitting there. So that's too far forward. That's perfect. So now we're looking at whatever off our baseline was, which I didn't record, and it might be, I think it was about, it's probably about 300 or 400 forward of our baseline. So 0.4F or something like that. Maybe that's the code in the chainage is 2 3.6s. So pretty easy to work. So you just write your numbers along there and you adjust your values. Go off to hole number 4, and again, so this is how it works, right? And you just keep going through this method here, and let's go 13. Maybe it's a bit more, 15. Now I'm sure there is an automated aspect to this tool, but I like to do things with a mindset of ensuring that we do it with knowledge about our choices, and automation stops you from having that knowledge. Now automation's great if you know what you're doing and you trust what you're doing, but knowledge about why you're doing something is far more important. I think this fact that people just want to give their abilities away. They don't even know why they're doing something. So I think this is key. Get your mind in gear about what you're doing, why you're adjusting something, what that method was, and this is all part of the design engineer. Why are you doing it? Is it right? Is it wrong? Do I need to improve? Do I need to let the computer do what it does and just ignore it? And so we might go 9 here. Seeing that we get in a 9. Steepen it up. Maybe it's 8. So you see, as you can see, this blast hole is fluctuating in amount along the face. We're getting a bit of a wobble there, and so we're just kind of plodding along and designing our blast. I think that was probably okay, that 10. Maybe it's a bit steeper than that. 7. Looks like a 7, maybe even a 6 to get that across the board and forward. Yeah. So here, now you can see this. Let's say you really wanted that to be the case forward, then you're sort of like, you're in the warning state. So now you need to think about increasing your stemming on this particular hole. Perhaps you want to increase the stemming to 4 meters so that you don't blow out the crest, but you really want to place it in this position. So this is the important aspect of face design, is you need to consider your charging, where something is underburdened, overburdened. So we can say, well, we can move it back 100 mil, but then our toe increases slightly. We can another 200 mil back, and so we now got a 3.2 burden, where before we had a 3.0 burden, but we just had to reduce the stemming, increase the stemming or reduce the column height. So important little story there about that. And so just moving through all this, you can do all this if you like. We can do all of this, but it's going to take a bit of time because it's contemplative and I want to do it right. I don't want to show you how it's done wrong. When I talk, I also have great difficulty in doing, because I am thinking about the words to say. Oh yeah, I think that's good. You can. A different design engineer would do a different thing, right? They would do completely different design. Maybe they're 1 or 2 degrees off, 100 mil in and out. So it's your design is not wrong just because you made different choices. The choices are in your head, so you need to make sure that those choices are explainable. Don't do anything without a reason is the key to face design. Make sure you are completely, essentially it's blast design in the whole. Don't do anything that doesn't have meaning. I'm afraid to say that too many people do things without meaning or understanding. I like that bit better. Yeah, so we can go along all these holes. We've only got 4 to go, so let me just quickly do those while you're watching me. That actually worked out pretty good. We'll just add a degree onto that. And backwards a couple of hundred. Yeah, there you go. Maybe it's even 1 more degree, 12. Oh. That is not 12. There you go. 12 and backward. Yeah, I like that. That's good. It's amazing. This is a kind of a lost art, face design in mining scenarios. They don't have the conditions that require them to do this detailed stuff. They're a lot of the times, maybe perhaps in coal or in some urban areas they do, but certainly in the Pilbara and in remote gold mines, this is just not needed. You don't need to design a face. You just need to put a hole there somewhere that is relatively well burdened, that's not going to destroy stuff too much. Because just the other day on LinkedIn I saw an example of a face burst, and I think that's why you need to really pay attention on your face design and make sure that you're getting everything correctly done. Yeah, see here, you would make that choice. I think we'd keep it there, which means we're overburdening, but not too much, not too bad. Like, we're aiming for 2.8 as our minimum face burden. Obviously, we have a tolerance, and I think 300 to 600 mil on a 102 mil hole. That's reasonable tolerance. I mean, I don't think that extra 600 mil is going to stop it in one occasion. So you're just sort of like weighing up your options around what that means for you. 13. Oh, that's okay. I like that. Like this brown bit is what we're looking for here. This brown line through there, not this black line. So I'm just going to dial that back. And we see this. This is kind of, well, maybe stand it up a little. I like that. That's good. Radio. Maybe we can move it forward one. Yeah. 2. There you go. So we hit our number. So our face profile has gone from that very straight-lined face to this this in and out wobbly face. You know, we've got a wobbly face line there. Yeah. And if I turn this surface off so we don't see that, we can see the angle that those holes are deviating off. So that's tracing the face out along the face. So we're sort of like looking at how that blast hole presents to the face, right? Pretty easy to look at. Side profile's not matching because there we are, and we can see there's detecting minimum, and also looking at around that blast hole is looking at the wobbliness or the minimum. Sorry, I jumped a bit. The minimum face burden that it's searching for that face to say, well, I'm going to burst out here. If I have a chance of breaking out into the face and creating havoc, this is what these green dots are where the computer is suggesting that will happen. Right, so that's pretty much a face design. Now the key here is that we like this over here, but then we're going to do another design off this side here. Right, so let's select that. We'll put holes in along that line. 102, yeah, sure. That was pretty silly, wasn't it? I'm going to have to undo that because I've got 6 meters here, and that's not what I wanted. So we will undo. There you go. Holes along the line. We're going to go 3.6 again. We're going to do the spacing, but this could be, because these are going sort of like out this way, this could be a burden distance. But I mean, let's say we do a 3.6 by 2.8 or something like that. It's pretty much equilateral. So the distance along this line might be exactly at 3.6. So we'll just say 3.6 at the moment. I don't know what this direct business is going to do. Let's try direct. No, it didn't make too much difference, but I like it enough. And so we place those holes. We don't like this orientation here. So you know, this is this orientation. Don't really like that. We're going to point it out this way, yeah. And so you can individually move these, and I think we're going to put this one out here because I'm foreseeing on this case here that this will push back and be around, and we probably might want to shuffle it up a little bit. So I'm not entirely sure. That was pretty silly, wasn't it? Not entirely sure. Whether these are good value. This is a good value. So we just turn around here. We're just going around here. So we're just roughly getting it right. But you could just select all of these and have a consistent thing. So we can do that as well. Let's do with our group 2. Using a small screen, it's tough because you can't see everything. So here we've got that, and we can say, well, I think like this is in there, but if we select just one of those holes, what do we got? We got like kind of 12, a bearing at 12 degrees, it's saying. So let's select these holes through there, not that one, because we like this one unselected, and we will make sure that these are all 12. That's all 12 bearing. I like that. They all look pretty good there. And our inclination on these are all going to be 10. That is insane what that's just happened. So not sure why that's done it that way. Alright, let's 70. What do we got there? 172 maybe. Negative 172. Radio. 4. 5. No, we're going backwards to 170. Negative 170. Radio. Alright, kind of like that. And it's kind of odd that it's doing this calculation this way, but maybe I've messed something up. As I said, I'm learning this program as well. So I think this direction is the problem of the. Yeah, there you go. I've directed the blast. I've said look at the blast hole backwards, which is not good, right? There you go. So we'll turn all these around, and this one we had it back this way, didn't we? So we'll fix this one up manually. We're going to say this one's going to be like 160 or something like that. Yeah, that's good, 160. And we'll hit with a 10 to start with, just because that's probably what we were aiming to do with it. All right, so again, so we've done these blast holes. Great job with their direction and everything, and now we're going to place it. So we can go look at these blast holes. This particular blast hole 20, and we're looking at this face profile, and we're also thinking, well, let's think about the distance between here. The distance between here is, and we kind of want it midway. So I'm not going to measure it out for this occasion, but we'll move the blast hole, if I can find my tool correctly, the move tool. Yeah, move tool, and we're going to move this blast hole. Here we go, back a bit and across a bit. Yeah, maybe even forward. Just so that we're sort of like equidistant between those two, because really the bulk of the energy's been doing out here. We'll finish that move tool back to editing. Pretty simple stuff. So I'm 38 minutes. I'm just trying to better talk a bit quicker right here, because I don't want to spend too much time on this. Like I don't want the streams to go for more than an hour. I mean, I think even an hour is pushing it if you're not interested in the topic. So here we can see that, you know, we got to go steeper, and so this is essentially blast hole face design off a baseline. This one here is the only one that would be difficult to mark out and get accurate, but you would sort of like be calculating the distance between these two and then drawing a line and then running a perpendicular line out there and saying, well, that's where I want that blast hole to be. Yeah, so here we have this level and this blast hole, and so we're sort of like merging them through like that. So, you know, we're now looking for it. Now this corner might be overpowered a little, but this is still a face hole, even though it's kind of behind this. It's probably firing at a similar, like when we finally do the timing, it would be firing similar across there. So we can continue on and do this and say, well, you know, eight for that, and looks pretty good, and we'll just move that forward, see where we ruin our blast hole. Important to get that line up the top there. With 3 point, I don't mind that. It's right on the line though. And here definitely got to move forward, but we should be standing it up to about a 6 again, I think. And we'll go forward a couple of 100 mil, or quite a bit. Oh, it's decided to fail with the calculation. Just bring that up. Now you can see that this is quite time consuming, especially for me, because I'm talking and thinking at the same time, and unfortunately I don't have a brain that works that way. I just have a brain that does, thinks, and now I'm trying to talk and think at the same time. So you can see that this has moved way forward, you know, but it's much steeper. But the point is not the position of the blast hole. The point is the position of the blast hole on a face is the point of the position of the blast hole to the face, and that the blast hole is evenly burdened across that face. The toe's not overburdened, the crest's not overburdened, the center of it's not underburdened. So it is important to think about this in a different light of than what you would think about if you were doing just a normal production blast. And maybe this baseline that we set out here was too far back, because there is no way. The longer you in the field, if you're working in the field and you want to do these adjustments, the closer your adjustments are to the baseline, the less wrong you will place them, if that's a word. So we go one more or two more holes there, and so both of them are going to be forward. So I think we will just grab both of them at this stage. We'll go forward, move both of them forward, and we will steepen both of them up to about an 8. Right, we've done our first sort of pass there. That's pretty close. I think we'll go 7 for this one here, and we'll move it backwards 2 steps. There we go. That's great. And then our last blast hole, our last face hole, well, it's a 7 as well. So maybe I could have saved myself a step by being able to do that right. And we'll go backwards again. Actually, it's more like 6. Not 67, 6. And go forward. Rightio. Okay, so now we have our blast face. We'll reset that to north, and we'll fit all, and maybe just fit holes. There you go. So now we have our blast face. Now this is, I'm kind of, in reality, I might have moved this off over a little bit so that we gave this hole a bit more space, because this is only really 1.5 meters away from the other one. But the toe lines are quite interesting to think about. Yeah, no. So we're thinking about the relationship of these blast holes at their toe. If we look at just that, we can see that they're relatively well spaced at the toe. They're interesting. Even though they're close at the collar, they're relatively well done at the toe. Maybe we could have moved this one across and minimized the distance between, because this one has such a large hypotenuse between the two values there. You know, this is much bigger, so perhaps this could move across and give space for this one. A bit of a evening. So what we're trying to do there is even out this energy, because if we're far too close to either one of these holes, we're actually increasing powder factor, and this is a relationship. So when a hole's closer, you can either reduce the charge, or you can change the timing, or you can you know, or move it. You have to move it away from the other hole to ensure that your energy is much more consistently applied to the rock mass. Rightio. I think that's a pretty good method for this, and I'm just gonna rename these to face 1 baseline method, and this will be face 2 baseline. Okay, now I haven't changed the charging, but you could change the charging in here, and like we said, if we had an overburdened or an underburdened crest, we could increase the charge, and especially if you were like doing a kind of helper hole, an assisting hole, you might want to consider that, adjusting that. Okay, so we've got our 2 baseline sort of stuff in there, and we can turn those off. We're going to do a different method now, turn our baseline off, and then we've got this 3-dimensional surface, and our other option here is to digitize the toe, and then offset the toe in with a minimum burden preference, and then place the holes offset again from that using what we expect our projection difference to be, so our planned difference from collar to toe separation. Here I've got crest to toe, but you can say collar to toe, it is the same thing. Alright, so we can do that. So let's, well, I can either digitize it or I can just use the digitized one. I think you know what I'm talking about. Essentially, we're just going to draw a line along the toe here like we've done here. And if we go into 3D view, there we've just sort of like, you know, done this digitization around the base of the face where our minimum burdens. This one's a little bit high. You might want to move this one. Yeah, just running this through a virtual computer, like a remote desktop connection, so on my Surface, so it's a little bit laggy at times, but you know, so you kind of like digitizing. Maybe there's a few there that aren't in quite the right spot, but you get what I mean, right? I've digitized the toe line, and then from that digitized toe line I'm going to offset it, right? So let's we've selected it, and we're going to create an offset line. Now, what was my offset line? I've got 2.8. I've already set it at a custom 2.8, so that's okay for me. I'm pretty happy with that. And so we can do 2 things. We can offset a 2.8, and then, which is our minimum face burden, or minimum face burden that we're trying to like not go below, and then we can offset that line again by 2.3, or we can use the tool. The tool in here, the along the lines, actually has an offset function, which I'll show you instead. So I'm not going to offset another line, but we're just going to fix up a few of these calculation issues around this. Let's see. Well, here you go. Face offset. So we're just going to grab those and get rid of some of these kinky stuff that's happening. So like smooth it out a little so that it's not sharp, because this will give us problems if we have a fold in it, in the face, like a crossings of the crossing line, then the hole might end up a bit odd. So essentially we're just going to take some of these kinks out pretty quick. Actually, I'm getting more and more used to this program. Initially, I had concerns about how intuitive it was, but once you kind of know how the application's laid out, it's relatively simple to use, and like with all applications, the more you use it, the better your experience. So here we have our line, and what we're going to do is just this is the case where we didn't have a scan, we don't have a baseline, we're not in a quarry, we're in a mine site. The drone's just flown over. It's done it's done a scan of it, or the LiDAR's come back and for the monthly plan, and this is ready to go, and you've got all the GPS coordinates. So you're in the office, in the air conditioning, and you're kind of designing. All right, holes along that line, absolutely, and I don't know why it keeps jumping that. It's one of my settings. I've got to sort that out. So we've got this point. Now this is essentially where we're thinking about our holes being on the toe. So this is like just set my headphones a bit better. Our holes toe would be along this line, but we're not going to do that. We're going to be shifting them back. And what did we say that we said we were going to do? It was 2.3. That's what our little chart suggested, 2.3. And if you're a little concerned about that, being that 12 is really the one, or you want a bit of meat in it because you think you're going to move it all, have to adjust them anyway, which you probably will have to adjust them anyway. Yeah, let's just do 2.4. Yeah, just give ourselves a bit of calculation meat. Right, there you go. And as you can see, it's generated a set of holes offset from the original hole. We've got one outside the boundary, which is okay. We can go delete that, and we can create those holes. Okay, and we have the same issue again with these holes being presented that way, but there's absolutely must be a setting for this in there that I just don't know anything about. So that's okay. It's a fairly easy fix. Here we're just going to grab all those holes like we've got already selected, and we're going to give them a set bearing, and it's saying it's at, so like maybe it's adjusting, so let's just suggest that it should be like 125 for this section. Alright, so here we are, all pointing out this way, one angle, and then we're going to go and grab this line of holes off this side here, select these holes, and probably going to delete this one on the end, and then we want to project it out. And what did we have? It was sort of like 180, a bit past 180. So in this case, for this program, it's like a negative 175. That's okay. Maybe 170. Really, it is up to you. There, decide. I think 170 is fine. And then we have one hole that was in here that should be around here, so that should be 180. So let's do that at 180 due south radio. I think we're good. So mostly our holes are done. But what's the problem here is I don't think these holes are snapped to the surface. No, they're not. So as you can see, they were generated off that line, and that line was not on the surface. So how do we fix that with this program? We're going to move those holes up with the placement editor. We're going to snap those holes. I'll just move this down so you can see what's happening. And we will select all holes, and then we're going to go to the placement editor, and we're going to move direction. Well, we're going to move them up. We're going to turn off the preserve toe at this stage, and we're going to aim for the collar. Pretty easy. Hole inclination, awesome. Let's do it here, 10. We'll apply the inclination. Hopefully that's applied the inclination, and then we're gonna and then we go perform the snap. It's done it all together. So when we applied the inclination, it's performed the snap, and it snapped it to the surface. These holes I mustn't have turned off. Did I not turn that off? Yeah, I preserved the toe at elevation, So that's a bit of a problem, isn't it? Well, that's okay because I've got actually a base, a toe blast surface here. Yep, so I've got my toe blast surface. That's insane. This remote desktop is a little bit clunky and slow for me. Right. And we're going to aim for the toe. I've selected the surface and I'm going to preserve the collar. Yeah, I think I am going to preserve the collar in the position. And I'm going to perform a snap. I don't need to worry about that. Consider subdrill. What did I have? I think I had subdrill included in this surface, so I'm going to perform the snap there without considering the subdrill. Let's see. Yep. So it has now lifted those holes up to that thing, and they're about 13.2. So that's worked out well. All right. Let's go back to the plan view, see what sort of mess we've got. Oh my goodness me, it's moved these holes around. So we now get to decide which hole we want to keep. I think we're going to definitely ditch this one, hole 28. Let's just delete that. And we're going to take this hole and we're going to rotate it around a little bit more. These look a little steep to me in some spots. 18, yeah, so it's done a bit of a calculation based on the position of the blast hole. Be interesting to see what happened there. But anyway, we look a bit further out, don't we, because these holes are at a higher angle. I wonder if we just undo this and see where we went wrong. Kind of freezing up here as I go. I suppose because it's doing a lot of calculations on the fly. See, that's what I want to actually move the holes back. So I've done something wrong there. It's not the program's issue, it's my issue. Let's go for the placement editor again. I'm going to select the blast surface here. Yeah. Blast surface, yep. And get the placement editor in. I'm just going to watch this in a plan view instead of what we did. We're going to preserve toe, then we're going to take that off. We're going to search for vertically and we're going to go up, and we're not going to fiddle with this. We'll just perform the snap on the collar. So we'll just get the holes snap to the surface. There we have it, and then we can then look at the blast toe. Right, and we can snap to the toe if we want. But let's just work with what we have now. So I'm going to undo that, close that. I'm going to adjust the inclination on that. I'm going to grab the inclination off these blast holes and do it manually because I think it will be better to do it that way. Yeah. Select all children. Right, here we go. We've got our angles sort of, or what we've decided on, and we will increase our hole inclination. We're just going to hit with the 10 that we originally said. That's what we've got. Our holes are all set up. I like it. Let's see what we've got there. Go to the 3D view, and so this is essentially designing a face. And then we need to just move these holes like we did before to minimize their chances of bursting out and breaking through, and we just do that as we said. Got too many options there. Yeah, hole 1. Oh, which one was that? Yeah, group 1. Let's just go over here. Grab this hole over here. And we can see on this cross section here, we're overburdened, underburdened, all that sort of stuff. Now, originally we had like a 12 degrees, and we'd moved it around, so it's not quite where it used to be, but the inclination, let's hit with 12 to start with. And now we're going to move back until we get that in the right spot. I think 12's, yeah, 12's good. Well, that's what we had with 12 before, so it's roughly the same. It could be probably a little, oh, I kind of like that. It looks really good at 12 degrees. Okay, so it's all fairly consistent on that burden at 12 degrees. And then we just keep going through what we did before, essentially exactly the same stuff. This needs to move forward a bit more, so maybe it's 15 in this section of the area, and we are moving it back again. Obviously, once you are aware of what the program's doing, you will be more appreciative of how to quickly find and work through the problem. So that's pretty good up until this bottom bit, which is a bit overburdened, but I don't mind that. I don't mind that at all. So pretty interesting sort of scenario that we're doing here, and so you just go through and adjust all these, and that's how we are designing the face. So there's two methods for you. One is in field. I mean, having a face profiling system like this, most programs have. Vulkan has one. Well, Paradigm has it. There's other ones on the market. You can also do cross-sectional views in BlastLogic, which is another MapTech product. I'm not sure about ViewShot. I don't know fully, but I think you have a 3D view of this. I've never used it in ViewShot. Not sure whether it does a separation, but there's lots of tools on the market that do this sort of stuff. I'm sitting at 1 hour now, so I think I'm going to call it quits. I don't want to go too far over, but you get the method and the tools and how to do that. I hope this was good. I need feedback on the video, so if you comment on the YouTube video, it changes the algorithm so that people say, oh, this video is getting interaction, it's getting audience engagement. So that audience engagement means that I will be more visible to other people, other people that may be interested in this topic, and then those people will see it through YouTube, and then so forth and so on. So if you can like the YouTube videos, even if you watch them, maybe even if you don't like them anyway. And then, or if you think it's trash, then dislike it. Be honest. I guess that's I prefer to be honest. Put in a little comment, like, subscribe, share with your friends if they are other engineers, share with your superintendents if they're interested in a concept, share with your mine managers or something so that they can get a perception around the detailed work that an engineer has to go through when they're doing a blast design. So that there's a lot of times people are ignorant because they haven't taken the time to understand someone's position or topic, and they think they're one way or the other, or they think they're carrying on in a meeting saying it's impossible and they're being antagonistic, when really they're just looking for the answer they want. What they really need to know is how to learn and how to appreciate somebody else's role in the world and how they play a part in the functionality of a mine site and the functionality of a society on a greater whole. So having that understanding about other people's perceptions and feelings about a topic is very important going forward for the world. And no more important than in Drill and Blast. So if you can educate people, like, share, subscribe, I've said it before, if you just do that, if you just like, share, and subscribe, that is good enough to help me out. And if you don't want to like, share, and subscribe, but you still like the videos, but you don't want your YouTube feed scattered with weird blasting videos, then maybe even just to support me over at buymeacoffee.com, or go to the Streamlabs store and you can donate to me directly, or you can try and buy a piece of merchandise if you like it. I mean, it's pretty lame merchandise, but please go and have a look, and like, share, subscribe, and hope you enjoyed this, and let me know if it's something you like, and if it's a video that was worthwhile and gave you a bit of education, then please comment. But also just support people sharing their information. I think information is important, knowledge is super important, and I think we all need to share that. So appreciate you all who have mentioned that you like the videos, and I appreciate you all who have supported me, and I appreciate all the people that have been understanding of my situation. So awesome. Please like, share, subscribe. Really appreciate it. Like, share, and subscribe. That's it, pretty much. Stream's over.